back, you know, if in your discipline something exists pre-1984, which it probably does, and so you will get a sense, because if you keep looking, there will always be the next paper that came out today, but at some point you have to be done and you have to submit it, and then people will start citing you. Or in your next paper, you'll cite the additional stuff that came out. But it's sort of like in, you know, how in taxes you sign the form based on the information, I think I did the best job and I didn't, you know, break the law. Well, based on what, and hope you didn't, based on what you know today, after a thorough and extensive and not trivial literature search, this is what you're saying. And this is how your data fits into what is available today. But if you're not done, you'll never publish. You'll keep adding another paper and another paper. So at some point you have to say, I'm done.
Can I tell you a story? Yeah, my personal. You've got to go back 35 years when there was no internet, no nothing. And I did, that was
hard times.
Hard times. And
for literature. And
in fact, my PhD thesis was a physical chemistry, catalytic oxidation of phenol and aqueous solution. And I used to go to the chemistry library in Delaware, off and on. And you know, in those days you had journals, Russian journals and German journals. Some of them were translated in English. Guess what? I saw a paper, it's translated, and in catalytic oxidation of aqueous, phenol, etc., is a free radical reaction. My advisor didn't know it, I didn't know it, but that day when I saw the paper, I knew my thesis was done. Now it's just a matter of getting the number of experiments and getting it done, etc. So I looked at the paper, got the mechanisms. My advisor kept asking me, how are you getting these mechanisms? You know, you seem to be a little bit ahead of me. I didn't want to tell him, but eventually I broke down and I told him, you know, hey, there's a journal in the library which is translated, which has the oxidation, not of phenol, but other organic compounds. So the moral of the story is do read a lot. One sec. Not only read a lot in your own area, this guy from Purdue also said, just go to the library. Okay? Now I do most of my stuff in mathematics. It's just go, not necessarily to the section where you generally go. Go to another section. You never know what you might pick up. So I can't overemphasize reading. I know with the internet, etc., you guys, most guys would, I do it too. You know, you go to the internet and out comes the information, but you can't overemphasize the going into different areas, and somebody else may have done similar work, or, you know, for example, I deal with mathematics, and there are only so many partial differential equations. There are only so many solutions. So somebody or the other is going to have solved them. So just go, look it up. You'll save a lot of time.
In some ways, I think the internet has done and I know there's a lot, but has done a disservice.
Yes.
Because you can enter search words. See, in the old days, I used to go to the library and sit through and flip through the whole journal.
Yes.
And sometimes I would come across other articles that I didn't necessarily think that it was like, oh, this is cool. And I would start reading that, where now if you have an alert, unless it's specific to your discipline, it may not pop up. And so you may miss things within that journal, or also things in general. And just to build on that, you have to think outside the box, and it really is discipline dependent potentially. But let's say I'm a biologist, right? And so I work on coral reefs, but the same type of questions may be relevant for a plant herbivore kind of interaction. And so if I don't read the plant literature, or at least look at it, I may be missing a lot of really great ideas. And then the big journals like Nature and, you know, the PNAS, the big leaders in the field, they want to see a comprehensive overview. They don't want to see a coral reef article. They want to see how it builds into the big picture, and you'll get the big picture if you step out of your specific journal and think of how many different other aspects can work. And funding agencies like collaborative work from a multi-pronged approach and not just a narrow looking at information. And that's a better way to present your data anyway, if you have a broader look at it.
I think that, she's made a very good point of, in the internet, with the advent of internet, one only looks at one particular thing. But in the good old days, 25, 30 years ago, you're working in an area, you see an article, you go read that article in that journal, but lo and behold, when you open up the journal, and there are some other articles, and that's the point. And you'd be surprised how many a time, whoa, I came for this, and the whole slew of articles that.
Although the internet does have a version of that,
yes.
because when you read an article, it says other articles that have
yes.
cited this article or other articles, then you're like, you keep, clicking on other links and going forever. But it's different.
But the moral of the story is read a lot. Read a lot. And for your own benefit, because it might save you a lot of time. You hate to rediscover the wheel, for if you want to call it that. Somebody's done it for you, it's a lot easier. I must confess, I don't want to admit it, but I'll say it now 35 years from now. If I hadn't read that article by a guy called Gorkovatsky in Russia, I would still be stuck in Delaware. My advisor didn't know nothing, I didn't know nothing, and we would be struggling. Once you read that article, then it's just, then you get cross-references and all the other stuff. It's wide open after that.
Other questions?
If you cannot reproduce the results, reproduce how can you publish those results? Reproduce it.
Sorry, repeat the question again.
If you cannot reproduce the results.
Oh.
You've got a problem.
You got a problem, sure.
Because one of the basic foundations of science is to be able to obtain reproducible results.
And if you don't reproduce it, somebody else tries it out and he complains, and then he sent it to a journal that, the results are not reproducible, and that is bad. You get one bad thing like that, then
You've got to back up and start trying to find out where you're losing reproducibility.
Basically, I'm working on fungal metabolites. So when we scale up, we cannot get the same results what we did in screening, initial screening. So we use identical conditions.
Well, scale up smallly, in a small way. In other words, get a little bit bigger and see if you get the same thing. A little bit bigger and see if you get the same thing. And find out where it falls apart.
And then the other thing that you can do is report the results to that specific condition, and don't try to reach overarching broad generalizations that you cannot back up. So if in a test tube you got this result, then I wouldn't call the article the test tube result of the secondary or whatever metabolite it is, but report it for what it is. And if you can reproduce it within that, even if it's in a small test tube, then maybe somebody else would be able to, under identical conditions, maybe somebody else would be able to scale it up later on. But don't try to make overarching, generalizations for the entire environment if you cannot follow up with that. So you can't even do that in small reproduction?
I tried several times. I talked with several scientists, and they said they had the same problem with these fungi. Maybe that's their own biological system problems, genomics.
Well, it may have mutated or something quickly that you can't reproduce it.
But
Well,
that's
I would.
Different approach,
Well, I would check their genetics. So if you have the capabilities of doing genetics, you may see that they're mutating so rapidly and turning on genes or turning off genes or whatnot, or different genes, right? If they've mutated quickly, and that could be a paper. The rate of mutation in this fungal species.
Nothing is wasted. You just have to step back and look at it from a different direction.
You raised the point of reproducibility, perhaps I can go off on a tangent on that and say that never fabricate, I'm not saying you're doing it, never fabricate results. Because if you fabricate results and they are published, somebody always will try to repeat it, etc., etc.
Well, I got to tell the story.
You got a bad name for life, but go ahead. I'll pass it on to him.
I have to tell a story.
That's it.
I work for the Journal of the Electrochemical Society, and it's a big job. It's, you know, it's more hours a week than I would care to admit in public. And it's being a journal editor, particularly for one like this that has a high throughput, means weekends, vacations. I'm sitting at my vacation cabin, hooked up to the internet every night, and it's not really good for a marriage. But anyway, we'll leave that part.
That's besides the point.
We'll leave that part for another day. So we recently changed the head editor. I'm just one of several associate editors. We changed the head editor, a very prominent scientist who's at a very prominent school in the Midwest. And we got a new editor. And the old editor began to do some research very similar to mine. And I got one of his manuscripts to send out for review. And I started reading the manuscript because it was on the very same topic that I work on, anionic liquids. And I came to a passage in the manuscript, and I said, you know, if I wrote that passage about those results, that is exactly what I would write. And then I looked at it for a second. And I took one of my publications that I had published about a year or so, and I compared them.
Ouch.
And by golly, it is exactly what I wrote. And so I called up the editor emeritus, and I said, this is not his name. I said, Bob, I said, got a problem here. I said, one of your students has submitted a manuscript, and you've signed off on it, that has taken parts from my manuscripts and sort of inserted them in. Now, this is a man who spent a good 15 years of his life trying to do everything just right. And there was this really long, pregnant silence. And the last word I heard was, oh my, I'll take care of this. So these kind of things do happen, particularly if you are an international student and maybe your facility with English language is not that good, then there is always this tendency to perhaps borrow things.
Borrow, in quotes?
Yes. Borrow things.
Yeah, but not put it in quotes.
And it is, not to sound religious, the path to hell when you do that. And those of us that have international students, and I have several, I've had a large number of international students, and I always tell them, when you write the first draft of any kind of manuscript, thing that you're going to give me, you do the best you can and you write it in the best English that you know how. And I'll go back and I'll correct it. I'll fix it. But when I get to one of those passages in a manuscript and it sounds really good, and I know that this student has struggled with English during the entire time they've worked with me, then I really get suspicious and I get paranoid about what might be happening. So it's not worth it.
Well, more than 9 consecutive words is considered plagiarism. And even if a person writes the, the citation at the end, if it's not in quotation marks, it's plagiarism.
You have to be very, very, very careful, in other words, too.
And yet you don't want your whole manuscript to have quotation marks. I mean, you should have your own original thing. I'm sorry.
I'm so paranoid about it myself when I write that if I have more than 3 or 4 words that are the same, I consider that to be on the edge.